Welcome back, page 3 of our Pythagorean theorem notes. Remember, we're working with the Pythagorean theorem, which says a squared plus b squared equals c squared. Let's do a couple more examples here. Work through these 3 examples, and then we will be free to work independently today. We have 144 on the hypotenuse. Okay? Notice that this is our longest, our slanted side, so it is our hypotenuse. 144, that is our c. What do these little red lines mean? Well, those little red lines mean that side A and side B, or side X, are the same length. Those little red lines denote that they are the same thing. So what does this side length equal currently? Well, if this one's X, this one also has to equal X. So how many X's do you see? You see 2 X's. Okay, and you see a 144. 2X is A and B. And then we have C is 144. Let's set this up as if it were a Pythagorean theorem, a squared plus b squared equals c squared. Okay? If we have a squared and we have b squared, remember they are both x, that's going to equal c squared, which is 144 squared. Right? Well, again, we have 2 of these. So what do we have? We have 2x squared equals 144 squared. So what can we do? Well, what we can do is we can simplify. Let's simplify this problem and solve for the variable. First thing you want to do is get rid of these exponents if you can. You can't get rid of this one yet because it's not a variable. So we're just going to rewrite it. 2x squared equals 144 squared, which is a big number, 20,736. 144 times 144. Okay, so what do we do now? Well, we need to get rid of that 2, so let's divide by 2. And we're going to end up with x squared equals 10,368. Now, what can we do? Well, just like every other problem with a square, we take the square root. Not a perfect square, just so you know. So x equals the square root of 10,368. That's all it is. Okay. Pause the video, see if you can work through this one here, and do the same process. You have these red lines, meaning that both side lengths equal x. That's an x, and that's an x. Do the same thing that you did here, but with a new number. Okay. Now that you have paused and tried this out yourself, let's solve it. Oops, sorry, press the button on my little pen here. We have x squared plus x squared equals 121 squared. 2x squared equals 121 squared is 14,641. Okay. Let's solve by dividing by 2. When we divide by 2, we get x squared equals 7,320.5. And we'll do our last step, take the square root, and get x is the same as the square root of 7,320.5. It's not a perfect square, so we just leave it the way it is. Let's try this one. Looks a little funky. We have 2 missing side lengths here. We've got a y and we got an x. Notice that I use blue and red here. Blue for a leg, y for a hypotenuse. And notice that we have a couple different triangles. We actually got 1, 2, 3 triangles in here. Okay, so what we want to do? Well, we can use the Pythagorean theorem to solve these triangles. Well, which triangle has 2 side lengths already measured? Is it triangle purple or is it triangle green. Which one has two side lengths? And which one do you want to do? Well, they both have two side lengths. They kind of share some. In triangle green, we have side 12, and side X. In triangle purple, we have side length 4, we have side length 3, and we have side length Y. So which one do you want to do first? It doesn't really matter. Let's pick one. Let's do 3, 4, and Y. Let's solve it. Legs, because they make the right triangle, or the right angle. 4 squared plus 3 squared equals y squared. Why did we do it that way? Well, because y is the hypotenuse. Y is the c. A squared plus b squared equals c squared. Let's simplify. 16 plus 9 equals y squared. 25 equals y squared. And then we take a square root, and we get that y equals 5. There's your answer. Okay. Now let's figure out this one. This one's missing a leg, not a hypotenuse. So let's figure that one out. Extend my page here a little bit. We have 4 squared plus x squared equals 12 squared. X is a leg. Let's keep going. 16 plus x squared equals 144. See if you can solve it from here. Pause the video, try to finish it up. We need to subtract 16 from both sides, and we're going to get x squared equals 144 minus 16, which is 128. Lastly, we take the square root of both sides, and we get that x is the same as the square root of 128 because it is not a perfect square. And you got the answer to both of those problems. That's it for Unit 7, Lesson 2, using the Pythagorean theorem to find the missing lengths of the sides of a right triangle. If you have any questions, send me a message on Schoology or post a comment on the video. Look forward to getting back into the classroom. Have a great day.